Palo Alto Network's firewall, decryption concepts. We're going to start taking some things apart so that we can look inside and see under the hood a little bit. So decryption policies are created really to increase the firewall's visibility and controls into traffic that's passing through. So as users come in from the internet to my application servers, or as my users and clients go out in there, we want to be able to look into otherwise encrypted traffic. From a firewall standpoint, or from my Palo Alto standpoint anyway, this applies to both SSL and SSH protocols. This is a great way to make sure those protocols are really being used as they should be, and not to tunnel other protocols or to do illicit data transfers, send things out that shouldn't be happening. So when we look at stuff, and I'll go ahead and kind of pull my flow diagram back up here real quick, in the overall process of where we're at, okay? So looking at my application stuff here, notice my decryption policy. As I look at what's going to be going on and evaluate where I'm at, I will know whether something is supposed to be taking place here or not. So I'll see this information kind of as it is, if you will. So when we get down to it, that's when we know to enact that information. Clear this back off. And as we go through, the whole idea is that my firewall is going to act as what we call a forward proxy. So basically, it's going to insert itself in there. Essentially, you're creating your own man-in-the-middle attack. So you're kind of attacking yourself, or at least your users and the anticipated traffic. But it's for good reasons, for good cause, really. And I know this is one of those arguments that we kind of tend to have of, are you invading privacy or anything like that? But in the end, your security policy, the thing that you and I are doing here is to protect your company. So your company's assets, your company's users, your company's intellectual property, your information, that's what is tantamount on there. So, there's always the argument of, if somebody's concerned about privacy, they probably shouldn't be doing whatever they're doing at work anyway. Do it at home, don't have to worry about it. So, that being said, enough of the, philosophical debate about what's going on. We have a policy, we have an action, we have a reason to do this, we have the capability of doing this. Let's get down to it. Now, it's important to understand a little bit about encryption to really understand what the firewall is going to be going through. Okay, so SSL, SSL and SSH, but the SSL concept, okay, change this, can utilize both symmetric and asymmetric encryption. Okay, make sure I get that spelled correctly in there. So everything that we have going in there, with asymmetric encryption, we have key pairs, basically meaning that each side has something different than the other one. If I have symmetric encryption, we both have the same thing. So like a pre-shared key or something along those lines, a common password, a standard password. And knowing what's going to be going on with this kind of helps us go through and really kind of see the things, like I said, that the firewall happens to be doing. So as we get into this, and I'm going to push in here and show a little graphic to go along with it that we will bring into this. So as we start to think about it, when we build stuff out, each side, so side 1, side 2, has both a private key and a public key. They also have a seed value, if you will, so something to get started. So let's just kind of go with the basics of it. We start with a seed value. We'll pick a color like yellow. And each side is going to choose what their private key is. They're not going to tell anybody else at all. So one side's going to pick red, the other side's going to pick blue. Now we have the ability of creating our public keys in there. So what happens in that exchange is we'll get our public keys created. So, we're going to have red and yellow on one side and blue and yellow on the other. We will actually exchange those keys. That's the part that helps us talk with who's on the other side. Now, a hacker in the middle may very well get copies of everything. They might know the seed value, yellow, that we started with. They might see the two colors that are public keys, so the green and the orange on there. They may understand that. But without knowing what those private keys actually are, it won't do you any good. Because the next thing we're going to do is we're going to take that public key, add our private key back to it, and now we have an encryption key. something that's shared in there. Now, granted, this is done with math and some really big numbers, so it's not quite as simplistic as what we laid out here. But the idea being the same with this, that we have things going in a single direction, that we can do these algorithms that really can't be undone. It's called a hash algorithm. You can go one way but not the other. So this helps us protect what the actual keys happen to be in there by doing that. Our private keys never leave. They are private on each side. And so that's going to be some of the descriptions. Now, the reason I kind of went through that and explained those things on here is in SSL, we go through a lot of the same type of events for it. So first thing is we have a request for SSL from the client. So let's call that a request right here. Then we have the server is going to return a certificate. Now, the third part is that that certificate is verified. So make sure that we trust it and see what's going on and all that jazz. I'm sure you guys have been to websites where something's come up and you don't trust the certificate, it's self-signed or whatever is going to be going on. But assuming that we actually trust it in there, what we're going to do is use that and help seed and create an encryption key. So we'll call this an encryption key exchange. And that kind of helps us. It'll use the client certificate, may use a client certificate as well, but otherwise just use a private key that happens to be on there. And of course that leads us to step 5, that we get encrypted communications. Now, with that, what I'm doing by setting up a proxy is breaking that communication. So I will have one transaction that goes from the client to the firewall. I will have a separate transaction that goes from the firewall to the servers. And all at the same time, the firewall is trying to impersonate both the server and the client on there. So we're going to be passing some information back and forth, or really paying attention to some information on there that'll kind of get into that portion of things. Now, when I do this, okay, so a lot of the stuff that we have to do, kind of going on. Every certificate is all going to revolve around having certificates. Okay, every certificate, so cert stuff has what do we have? We have an issuing authority. So basically, a certificate authority. We have a what we call key usage, which will dictate how the key is allowed to be used, whether it be for site verification, whether it be for email or whatever it's going to be. I have a validity period, so a date range on it. I may have subject, which is also called my name, or DN, distinguished name on there. I have the public key part. And then I may have a digital signature. And that portion is optional to go along with it. But all of these things, the certificate is going to have all of that we can verify exactly what I got going on in there. So an authority, kind of looking at this, all has to do with trust. In the beginning, so back in the old days, like dinosaurs and stuff like that, we had one primary authority, VeriSign. Now, that's, of course, split off, and there's hundreds of different authorities nowadays. Actually, a good number of them are technically owned by VeriSign, so I'm not sure whether that counts or not. But there are more and more that happen to be coming out. You can also set up your own certificate authority. Now, unless you're a really large organization, you're probably not going to bother or care about that sort of thing. But, for example, most governments have their own certificate authority and their own certificate authority structure. Every certificate authority, will have multiple pieces. Change color here. We will have the root CA. So basically the top of the chain, if you will, for knowing everything. We may have multiple intermediate. Just depending on, again, the size of our organization and who's allowed to trust whom on there. And eventually we'll get down to the client cert. Now, what we have to do for trust is actually trust the entire chain. Now, part of that may be, and some kind of interesting things in there, is it depends on how many intermediate CAs that I have. On a Palo Alto, as an example, the trust limitation is set to 5. And really, we can't change that. I can't increase it beyond that. So if there's more than 3 intermediate CAs, I'm going to kind of have an issue with stuff. I won't be able to trust the entire chain on there. So that may be something to watch out for when we start looking at it. All root CAs form, pretty much the basis of our PKI trusts, the public key infrastructure, all that stuff on there. On the Palo Alto, you can actually generate your own key. Okay, that's going to be what we call self-signed. So at that point, you are both the root and the client all at the same time. Obviously, there's not a whole heck of a lot of trust there, but we, you and I, often go through into our browsers and trust things anyway, override stuff. One, because we may not feel like buying public certs, or it might not be as feasible for it, or, whatever the reason happens to be. But a lot of times we'll get away with the self-sign stuff. When I start looking at my overall process here, okay, so the way that we're going to be breaking up the communications and the way that we're going to be doing things, a forward proxy function essentially means that the firewall is inserting itself into this mix. It's going to intercept the client's SSL request. It'll forward the request to the server, but will generate a certificate kind of on demand. Okay? An SSL connection exists from the client back to the firewall, or to the firewall, a separate secure channel created to the server. This, firewall to server communication is where the firewall is going to be sitting in the middle, or how it's going to be sitting in the middle. Now, there's going to be a few things with this. I'm going to kind of go ahead and clear this off because it's kind of important to know some exceptions or caveats in there. So when we start inserting ourselves, and draw my line again, inserting ourselves in the middle of this, we have to pay attention to validity. At this time, it's taken from real server. So it'll mimic whatever validity is sent from here, or if the server's out here, whichever direction it is. It'll take that into account. The issuing authority, so authority, is actually going to be from the firewall's generated certificate, the firewall itself. Now, if this is part of your client's trusted stuff, then everything's fine. If it's not part of your client's trust, and this will most likely happen out here, out in the real world kind of thing, if it's not part of your trust chain, then you're going to get a pop-up error about invalid certificate or problem with certificate, something warning them. That's good, I guess. It's good because it follows the standard. We're not hacking intentionally, I suppose, is the nice way of saying that. So as long as you've got the trust on there, which means that from an internal standpoint, all of your users, you will want to have it trust the firewall certificate. And you may get a real certificate on here as opposed to a self-signed one. You can do whatever you want from that standpoint. But you're going to want to trust that firewall certificate so that you won't get pop-up warnings. You won't get messages all the time that irritates the crap out of the users. It may still irritate them anyway, but you just won't get a whole bunch of pop-up messages for it. So that's kind of part of the process in there. The other thing to know about is any packet capture, so any PCAP that we do is before decryption. And this is good from, I guess, a legality standpoint. There are ways around this also, so we'll kind of go into that in just a little bit. But from a legality standpoint, most of the time we don't want to have our decrypted traffic then floating around or going someplace else. So that's going to be the default behavior for that. So those are kind of things that we need to be aware of, I guess, with looking at these things. Forward proxy function, by the way, is to outbound sessions, stuff with unknown servers. That's the hashing that takes place. On the other hand, the other function for things would be for our inbound stuff. Okay, so things going in here to our own application servers. That's going to be a little bit different because the servers are under your control. Now, what we do with this is we take the SSL certs, so SSL, and actually copy them onto the firewall. So the firewall will have a copy of my server certificate right here, and this way traffic can be stopped right here and then restarted, resent back up here. This is kind of a way to decrypt and analyze before it's actually sent to the server, and it's completely without the user's knowledge. So kind of going back through our concepts on here, and again, things that I have control over. My outbound, my stuff to unknown servers, is going to be done as a forward proxy. This self-signed or the self-certificate on here may cause trust issues. Since it's outbound, I'm in control of my users, so I can tell them to trust the firewall and minimize my number of errors or problems. That'll be part of your workstation setup at that point. Inbound connections, so users I have no control over, that wouldn't help me at all. But my own application servers, which I am controlling, I can copy the SSL certificates, put it on here, and again, the users will be completely unaware of that process. Okay? Always watch, always look out for your local laws, regulations about what types of traffic may or may not be allowed to be decrypted. Such as like healthcare, financial transactions, stuff like that is very often off limits. So be very careful what you're looking at, what you're doing, how you're handling it, what the restrictions are, what you can or cannot get around. So that's kind of the cool part as far as my decryption goes and where I'm going to look at it. A few other things. The nice part about SSH and SSL is they're based on standards. There might be deviations with stuff, okay? Especially when we get to like evasive applications and things like that. If the session can't be decrypted, so basically something's broken on here, and I suppose let me get an idea for you. We have TLS 1.0, TLS 1.1, TLS, that's an L, 1.2 are all supported by the firewall. So that's a good thing. There are others, as we get to 1.3 or later on, that at least right now are not going to be supported and would technically break the decryption. If a session is broken by the decryption process, it's actually cached. Okay, so the information is cached on there and passed through. It's no longer going to try to decrypt it. So there may be things passed from the client to the server that we don't know about. It does last for 12 hours. It's going to be cached, and it'll try to redo it and everything else. Look at your logs, because it does log that information on there, because anything showing up in the log may indicate an issue for you. If it's valid, by the way, the site that you're getting those errors from, go ahead and add them to the exclude settings. Just kind of make your life a little bit easier. One last thing that we have available to us. The Palo Alto Firewall, well, certain models anyway, can integrate with something called an HSM. Okay, so an HSM is a hardware security module. This is a separate piece of equipment, so it may sit over here. Let's put a little H there. Not to be confused with a hospital, that's completely different. But the hardware security module is a separate piece of equipment that will manage, store, generate digital keys, and possibly offload information as well. There are 2 supported units right now. So the SafeNet Luna SA, and there's one from Thales, which is called an N-Shield. N-Shield Connect, I think is what it is. Okay, and right now, those are supported on, let's see, the PA 3000, 4000, 5000, and 7000. As well as the VM, so the virtual machine modules, 100, 200, and 300. So all of those will help offload some of that information, dealing with an extra piece of hardware in there. So that'll kind of help you as you go through and do your decryption and stuff. Larger organizations, the bigger that we get, may even have one extra deal. Okay, and I'm going to kind of make a little check mark over here, change a color for it. On the 3000, 5000, and 7000, we may have another feature called decryption port mirror. And that does exactly what it sounds like it does. It allows you to copy or feed the decrypted information, so the plain text packets, out to a dedicated device. Now, this is used for DLP, so data leak prevention, or network forensics stuff. So all the things that are done on there. It does require an extra license. So there's something called, I guess I'll write it up here, the PA decrypt. It's a free license, but it is something you'll have to call support and get for it. But that allows you to set up port mirror interfaces that will go out there. It's the only way we're going to be able to do that stuff. And that's just a small thing. I would just be vaguely aware of it, because like I said, it does happen or does work only with the larger devices on there. So lots of fun decryption stuff in there, getting us back, I guess, to some of our roots. Decrypt, with the P in there, as far as our SSL and SSH. We reviewed some of the key structures as far as what's being passed back and forth, mostly to kind of give you a sense of what the firewall goes through in acting as a forward proxy, and really kind of intercepting things on there. So remember, that was from the, we'll just say 2 unknown servers. On the other hand, we can use or copy the SSL certs on things coming in to our own servers. So going to give 2 different features for it. I talked about some of the other ideas, some of the more advanced features, or higher end ones, I guess we should say, on what we can do to pass off, to either offload the information or pass it to a network forensics or a DLP server along the way. So that kind of gives a review process of what the decrypt parameters happen to be, and next we'll get, of course, into the configuration of it. I hope this has been informative for you, and I'd like to thank you for viewing.